We have to prove that this left hand side is equal to right hand side for all n greater than equals to 0, and we will use mathematical induction for that. So the first natural number is n is equal to 0, so we will see whether the left hand side is equal to right hand side for the first natural, which is n is equal to 0. So when n is equal to 0, this one becomes 5 2 to the power 0, that's 5 left hand side, and right hand side becomes 5 here, 2 to the power 0 plus 1 is 2, so that is also 2 minus 1, so that's also 5. So left hand side is equal to right hand side for n is equal to 0. Now we assume that for n is equal to k, where k is any natural number, the relationship is true. We assume that, and so we write that accordingly. So 5 plus 10 plus 20 plus up to, when n is equal to k, this becomes 5 2 to the power k, and the right hand side is, and we are assuming that the left hand side is equal to right hand side, so like that, minus 1. So this is we get when n is equal to n is equal to k. Now we see what happens when n is equal to k plus 1. So if n is equal to k, when n is equal to k, if left hand side is equal to right hand side, we see when n is equal to k plus 1, that is the next natural number, whether the left hand side and right hand side equals. So we will try that if they become equal. So left hand side when n is equal to k plus 1 is 5 plus 10 plus 20 plus 5 2 to the power k plus 5 2 to the power k plus 1. This is the left hand side. Now up to here, this one is, we have said that this is true, so this is equal to the right hand side. So instead of the series, we will write right hand side when this one is there. So plus 5 2 to the power k plus 1. So it becomes 5 2k plus 1 minus 5 plus 5 2k plus 1. So it can be written 5 plus 5, so that 2 times 5, 2 to the power k plus 1 minus 5, it can be written like that, because this sorry, up to here and here, this is added, these two are added, so it's like basically it's 10 into 2 to the power k plus 1, but I have written like that, and then I can write it here because 2, this base is 2, this base is 2, here power is 1, so according to indices law, I can write k plus 1 plus 1. This one's power is 1 here, and same base, so I am just writing in terms of the power here. So it becomes like that, 5 2k plus 2 here minus 5, or I can write like that 2, or let me write like this way, so it's a bigger bracket plus 1 and then 5. So this is the left hand side. Now when n is equal to k plus 1, what becomes to the right hand side? We can see right hand side will be 5 here, 2 k plus k is, n is k plus 1, so it's like that, minus 1 inside the bracket there. So basically this is what I could have written like that, k plus 1 plus 1 minus 5. So this is essentially the left hand side, which was here. So what I have done, when n is equal to k plus 1, in the right hand side I have, instead of n, it's k plus 1, so k plus 1 plus 1 is equal to actually k plus 2, and that's the same thing that it was here, but I have written like this. So basically left hand side is equal to right hand side for n is equal to k plus 1. So we have proved by mathematical induction the left hand side in this problem, the left hand side is equal to right hand side. First we have proved that for the first natural number, which n is equal to 0. Then we have assumed for n is equal to k, where k is any natural number greater than n is equal to 0, that the left hand side is equal to right hand side. We have made that assumption, and then we went on to prove that left hand side is equal to right hand side for n is equal to the next natural number, that is k plus 1. And once we have done that, we have proved that the problem, in this problem, the left hand side is equal to right hand side.